Assalamu alaikum. My name is Muhammad Kamran and you are watching Physics with Muhammad Kamran. We are studying first year physics chapter heat and thermodynamics. हमने आइसोथर्मल प्रोसेस तक पढ़ लिया था. आज हम जो डिस्कस करेंगे वो है एडियाबैटिक प्रोसेस. Today we learn what is adiabatic process. Adiabatic process. So the basic definition of adiabatic process is that the process in which heat can neither enter nor leave the system. वो प्रोसेस जिसमें हीट ना ही दाखिल हो सके सिस्टम के अंदर और ना ही सिस्टम में से बाहर जा सके, उस प्रोसेस को हम कहते होते हैं एडियाबैटिक प्रोसेस. सो हम इसकी डेफिनेशन लिख लेते हैं. The process in which heat neither enter or nor leave the system is called adiabatic process. Just like isothermal process, adiabatic process is also an application of first law of thermodynamics. As we know, mathematical equation of first law of thermodynamics, which is the mathematical equation of first law of thermodynamics is Q is equal to change in internal energy plus work done by the system. As in adiabatic process, heat can neither enter nor leave the system, so the quantity Q is 0. In adiabatic process, Q is equal to 0, so first law of thermodynamics will be reduced to S. From here, we can learn two type of process in adiabatic process. One is adiabatic expansion and the second one is adiabatic contraction. First, we will learn as adiabatic expansion. Now, what is adiabatic expansion? For adiabatic expansion, let's see, we have a cylinder in which we have an ideal gas. The cylinder, piston of the cylinder is allowed to move. This cylinder is perfectly insulated, so heat can neither enter the cylinder nor leave the system. If cylinder is perfectly insulated with any types of material, insulated means heat can not enter or leave the cylinder. Piston of the cylinder is allowed to move in upward direction, or piston move in upward direction when gas expand, and piston move in downward direction when gas is contracted. In first case, we allow the system piston to move in upward direction, so gas is allowed to expand. Let's see, when gas is allowed to expand under adiabatic condition, what happens? This is our well insulated cylinder. In this cylinder, heat can neither enter or leave the system. When this cylinder is allowed to move in upward direction, the piston is moving upward direction, what happens? As heat can not enter or leave the system, while cylinder is allowed to expand, the volume of the system is increase. सिलेंडर का वॉल्यूम क्या होगा? इंक्रीज होगा. जब चेंज इन वॉल्यूम आएगा तो हमने पढ़ा हुआ है फर्स्ट लॉ ऑफ थर्मोडायनेमिक्स में, सॉरी, जब हमने हीट एंड थर्मोडायनेमिक्स में वर्क डन पढ़ा था तो हम जानते हैं कि वर्क is equal to product of pressure into change in volume. Here, when gas is allowed to expand, the volume of the system is changing. So here we get the work done. As cylinder is allowed to move in upward direction, volume of the gas is increased. So work done by the system. We also learn when we studying the work that there are two sign convention of the work. When work done by the system on the environment, the sign convention for work is positive, and when work done by the environment on the system, the sign convention for the work is negative. As in our case, the cylinder is allowed to move in upward direction. In this case, the cylinder volume is increased, so work done by the system on the environment. So our first law of thermodynamic equation will become as we see, if we allow cylinder to expand adiabatically, work done by the system, so work remain positive, and first law of thermodynamics equation will become as. From here we learn under adiabatic expansion, work done by the system at the cost of change in internal energy. As change in internal energy sign is negative, this means the internal energy of the system will decrease. So student, we learn that under adiabatic expansion, when work done by the system on the environment, the internal energy of the system will decrease. So we can learn as under adiabatic expansion, work done by the system on the environment at the cost of change in internal energy. When adiabatic expansion system do work on the environment, the internal energy of the system will decrease. Now we learn when under adiabatic system environment do work on the system, what will happen. For this purpose, we raise this situation as we are discussing adiabatic compression. Again, we have a cylinder which is perfectly insulated so that heat can neither enter nor leave the system. So our process will become adiabatic. As we learn, adiabatic is a system in which heat can neither enter nor leave the system. The piston of the cylinder is allowed to move in upward direction or move in downward direction. We are discussing now adiabatic compression. Adiabatic compression means the environment will do work on the system. At the top of the piston, pressure will increase, and due to increase in pressure on the piston move in downward direction. As a result, piston movement in downward direction, the volume of the system will decrease. When volume of the system decrease, what happens? When volume of the system decrease, the gas molecule become closer to each other. When gas molecules become closer to each other, they collide more time with each other. Due to their collision, their average kinetic energy or temperature will increase. We can prove this with mathematical equation. Let's see how. As we already learned, work done by the environment on the system is negative. From our first law of thermodynamic equation, under adiabatic condition we have del U plus W is equal to 0. In this case, when system undergoes adiabatic compression, the work done sign convention is negative. So our equation will become which as, from this equation we can see that when work done is negative, mean when environment will do work on the system under adiabatic condition, the internal energy of the system is positive. Internal energy of the system positive mean internal temperature of the gas, the temperature of the system will increase, as internal energy depend upon temperature. When gas is compressed by doing work on the gas, the temperature of the system will increase. Now we draw its graph. Under adiabatic condition. Let's say this is the initial state of this point represent the initial state of the system. The initial state of the system is P1, V1, T1. When system is allowed to move in upward direction and system do work on the environment, volume of the system will increase, as a result pressure of the system will decrease. From here the system volume is along x-axis and pressure is along y-axis. When volume is when pressure has more value, corresponding to that volume has small value. When volume goes to increase, corresponding to that pressure become small. So we obtain graph like as this. This is the graph of adiabatic process, which is the application of first law of thermodynamics. So student, please like my channel Physics with Mohammed Kamran to get the notification of my new video, which is physics of first year. Please subscribe my channel and share this video with your friend. Thank you very much.